Today we'll be discussing interference. What is interference? Interference is a physical phenomena which tries to explain the wave nature of light. Wave theory of light attempts to understand various optical phenomena exhibited by light waves. So, interference is a characteristic phenomena that is exhibited by light waves and it supports the wave nature of light. Wave nature of light can be proved by other two phenomena. Those are diffraction and polarization, apart from interference. So, actually, Thomas Young, he is the first scientist who demonstrated experimentally this interference in light waves. He is the first scientist, Thomas Young. Okay, one of the best examples that I can give you for interference is, the oil film, the film of the oil floating on a floating on water. So then that oil film, okay, that is floating on the water is of few micrometer thickness. Okay, so when the light, sunlight or whatever light it is, uh, when it falls on the oil film, it reflects from top surface and bottom surface of the oil film, and then the light, two reflected light rays, they try to superimpose on each other, and then we get different colors out of that. This is actually interference. Okay, so another example that I can give you is, when you are on the highway in the hot afternoon, let's say some vehicle has, leaked some fuel on the road. So you can see the oil film on the road that gives you beautiful colors. Okay, when you look at that oil film, I kept telling you what is oil film. What is film actually? Here, film is of few micrometer thickness. Then only we call it as film actually. So, in thin films like oil film or soap film, whatever it is, okay, when these type of films, when light falls on these types of oil film or whatever, then light tries to reflect from upper surface of the film and bottom surface of the film, and the two reflected light rays from bottom and upper surfaces, they try to superimpose on each other, and then gives us beautiful colored pattern, beautiful spectrum will be seen out of that. That is actually interference. Okay, so the superposition principle, that forms the conceptual basis for the explanation of interference. To produce interference, the light wave should be coherent. What is actually coherence? Coherence means the light waves that are going to superimpose on each other should have same phase difference. That means they should have constant phase difference, or otherwise zero phase difference. And they should have same frequency, amplitude, and wavelength, etc. Then only we call the waves that are going to superimpose, they are coherent. The phenomena of interference of light can be classified into two broad categories. One is constructive interference and another one is destructive interference. Okay, the constructive interference of light occurs when the crest of one wave perfectly gets coincided with the crest of another wave, or otherwise when trough of the one wave perfectly gets coincided with another trough of another wave, then we get constructive interference. That means the amplitude of individual waves will get added up, and then the superimposed or the resultant wave will have much higher amplitude than the individual wave amplitudes. Then we say that constructive interference has been taken place. During this constructive interference, the light radiations are in phase with each other, which leads to a significant increase in the intensity of the resultant light. So when two waves are in phase, when two waves are in phase, like here, these are two individual waves. They have, they are in phase. Okay, that means they have zero phase difference here. So when these two waves, light waves, superimpose on each other, we get resultant wave like this. The amplitude of the resultant wave is the sum of individual wave amplitudes. Let's say first wave amplitude is A1, second wave amplitude is A2. The, a resultant amplitude, a resultant waves amplitude is the sum of two individual waves, which is A1 plus A2. Okay, then we say that constructive interference is taken place because the amplitude of the resultant wave is much more higher than the individual wave amplitudes. Okay, we'll now try to discuss destructive interference. What is destructive interference? I try to share. Here, you see, the destructive interference, the destructive interference of light occurs when the two light waves meet each other out of phase. That means they should have, phase difference. Then, or otherwise, one crest and another wave trough, if they meet, okay, if they superimpose on each other, then we get destructive interference. That means the resultant wave amplitude will be zero, or otherwise, almost amplitude, almost intensity will be almost nearly equal to zero. Then we say that destructive interference has been taken place. That means the waves that are going to superimpose on each other should be out of phase, otherwise they should be anti-phase. Anti-phase in the sense, if the wave, the two waves, superimposing waves, if they have 180-degree phase difference, we say they are anti-phase. Of course they are out of phase, but we call them as they are in anti-phase. Okay, if they have some phase difference like 90 degrees or 270 or something else, whatever it is, like 30, 40, whatever it is, then we say that they are out of phase. If they have 180 degrees exactly, then we say that they are in anti-phase. Such waves, when they meet, okay, when they superimpose on each other, we get the resultant wave amplitude almost zero. Then we say that destructive interference has been taken place. The resultant wave amplitude is actually the individual waves, you know, the individual wave amplitudes, if you subtract one from the other, we get destructive interference amplitude. Okay, suppose let's say A1, first wave amplitude, second wave amplitude is A2, then the destructive interference, when it takes place, the resultant wave amplitude is actually A is equal to A1 minus A2, or difference between these two, A1 and A2. Then we say that destructive interference has been taken place. These are two broad categories under interference. So we'll see now what are the conditions for interference. The two light sources, okay, for coherence to take place, for the light waves to be called as coherent, okay, the light sources, the two light sources should be, they should emit light waves, okay, having same amplitude, same, frequency, same wavelength, and they should have constant phase difference. Otherwise they should have zero phase difference. There should be no phase difference at all. Then we say that the light waves that are coming out from the two light sources, they are coherent. Okay, the sources, the light sources should be monochromatic. That means they should emit single wavelength, single color. The light waves uh, uh, should be coherent. That means they should have same wavelength, frequency, amplitude, etc. Then we say that they are coherent. To view interference pattern clearly, background should be dark so that you can make out, dark from the bright very clearly. That means the fringe which is bright and which is dark, you can make out very clearly. Okay, background should be dark. And uh, the distance between screen and the source should be large. Okay, screen and light source should be very large to see interference very clearly, and background should be dark. Okay, to see the interference fringes very clearly. These are the conditions for interference.